Hello everyone, this is Sangeetha, Assistant Professor, EC Department, SNS College of Engineering. So in this video we are going to say about the data acquisition system. So it refers to the process of collecting, measuring and analyzing real world physical conditions or phenomena such as temperature, pressure, voltage, current and other environmental parameters using sensors. So the sensors are measurement devices and the software. So the main objective of DAQ system is to convert physical signals into digital data that can be processed, stored and analyzed by a computer or other digital devices. So it mainly uses a sensor. So data acquisition is the process of sampling signals that measure real world physical conditions and converting the resulting samples into digital numeric values that can be manipulated by a computer. So the data acquisition system typically convert analog waveforms into digital values for easy processing. So the main components of a DAQ is sensors, signal conditioning, ADC, multiplexer, data acquisition hardware, computer or embedded system, DAQ software. So the sensors that convert the physical phenomena into measurable electrical signals. Examples: temperature sensor, strain gauge pressure and photodiode for light intensity. And about signal conditioning, so the circuits that prepare the sensor signals for digitization. So this might include amplification of filtering, isolation and other processes to ensure the signals within the acceptable range and quality for the ADC. And the next one is analog to digital converter, a device that converts conditioned analog signal from the sensor into digital format that can be read by the computer. So the ADC resolution, example 8-bit or 32-16-bit, and sampling rate or critical parameters in ADC, and multiplexers that allows multiple analog input signal to be routed to a single ADC. This is useful when you need to measure multiple signals but we have limited ADC resources. And data acquisition hardware that houses the ADC, multiplexer, the possible signal conditioning components, and a computer or embedded system that collects, processes, stores and displays the data. This can be a PC or a DAQ controller or an embedded system. And finally we use software mainly used to control the DAQ hardware, configure measurements, parameters, acquire data and perform analysis. Examples: LabVIEW, MATLAB and Python libraries are used. So the overflow, that is the DAQ system workflow. That is first one is physical system, and transducers or sensors are used. So sensors measure the physical parameters and converting them into electrical signal, that is called. And then next stage is signal conditioning. So the raw sensor signals are conditioned to ensure they are suitable for digitization. And the next stage is analog to digital conversion. The conditioned analog signals are converted into digital data by the ADC. And the next one is compiler. That is, the digital data is transferred to computer or microcontroller for further processing. So the data processing and analysis is the last stage. In this stage the data are analyzed and visualized using the software. So the next one is physical system or conditions. So the common physical system and conditions are temperature. So for temperature, thermocouples, RTD, that is resistance temperature detectors, thermistors and LM35. So LM35 last video itself we have seen. And pressure, the strain gauges, piezoelectric sensors, capacitive pressure sensors are used. So it is mainly used for automotive testing, aerospace, fluid dynamics, weather forecasting. And humidity, force and strain. For force and strain gauges, load cells, piezoelectric force sensors are used. So it is mainly used for structural testing, material science, biomechanics and industrial automation. And displacement and position, LVDTs are used, linear, variable, differential transformers. Potentiometers, optical encoders are mainly used. The main applications are robotics, CNC machines, automotive suspensions, geotechnical monitoring. And voltage and current, voltage dividers, current transformers, Hall effect sensors are used. For sound and acoustics, microphones, piezoelectric sensors, hydrophones are used. So it is mainly used for environmental noise monitoring, audio engineering, underwater acoustics. So these are the main workflow. And the methodologies are, so the DAQ system are essential for monitoring and analyzing various physical conditions in real time. So they involve the use of sensor to capture data. So the methodologies are, so methodologies refer to the structured approaches and techniques used to design, implement and optimize the process of acquiring data from physical systems. So the first one is a sensor collection. So the DAS begins with a physical property to be measured. So examples of this include temperature, light intensity, gas pressure, fluid force. A sensor, which is a type of sensor selection first, and we have to calibrate. And next one is signal conditioning, filtering, isolation. It includes, and analog to digital conversion. It includes a sample rate resolution. So in sample rate we have to determine nyquist rate and choose an appropriate ADC, and we have to select high resolution. And next one is data acquisition hardware. So it is an interface type. So we have to choose DAQ devices based on interface types, USB or PCI or Ethernet. And synchronization, multi-channel synchronization and clock resources we have to select. And data acquisition software. Data management and storage, so data logging, storage solutions, data analysis and visualizations, and last stage is testing and validation. These are the methodologies are used. And the main merits are reduced data redundancy, reduced updating errors, and increased consistency, greater data integrity and independence from the application programs, improved data access to users through use of host and query languages, improved data security, reduced data entry, storage and retrieval costs. So the demerits are database systems are complex, difficult and time consuming to design. So substantial hardware and software startups costs. So damage to database affects virtually all application programs. Extensive conversion cost, moving from a file based system to database system. Initial training required for all the programmers. So these are the main demerits. And the major applications or process monitoring, that is industrial automation and control, environmental monitoring, and automotive and aerospace testing, and medical and biomedical research, scientific research and experimentation. Energy sector, and it can be used in power grid system, renewable energy systems, and it can be used for consumer electronic testing, geotechnical and structural monitoring, education and training, that is for laboratory experiments we can use. So hope this video will teach you the basics of DAQ. Thank you.